Okay, so I am recording. We will continue with radicals and exponents and logarithms for another class or two. Um, sorry, I'm just looking at something in my notes here. All right, cool. So last day, so it's been a while since we've done anything new because we had a review, or well, sorry, we had like didn't have class yesterday. Then we had a test yesterday. So this would have been done Sunday and Monday. We looked at radicals and logarithms. So today we're going to keep going with that and look at properties of logarithms. These are important properties. We're going to need these for the next few questions. So it would be a good idea to take a mental note of these. There's 7 different properties here that we're going to use today. So a lot of these you can, of course, do on your calculators, like properties 1 and 2. For example, the log base b, so I'll zoom in here so you can see it a little easier. The log base b of 1. So if you take the log with any, you can enter this on your Casio calculators. We looked at this the other day. So the log of any base b to 1 will equal 0. So, you could have log 10 to the 1. It's going to be 0. Log base b to b, so you could have log 5 to 5, that will equal 1. And again, the best thing about these two rules, actually even rule 3, is you don't need to memorize these rules for the most part. You can just do them on your calculator. If you had something like number 3, a little bit more complicated here, but if you took something like log base b to the b, so sorry I don't have much room here, they're not giving me much, but we will practice this. So if I had something like log base 5 times 5, and then I had that 5 raised to the power of 6, that would be 6. And again, these rules can be done on your calculators, which is really good. Now, the other rules, again, they can kind of be done numerically on your calculator, but rules 4, 5, 6, and 7 are rules where we have variables. So like B is kind of like a number. Where X and Y's, these are our variables. Now, all of these are positive real numbers. So, 3, 4, 5, 6, 7, 8. But number 4, 5, 6, and 7 show you some different properties where we have multiplication, division, and exponential rules. I don't think you're going to see rule 4 very much. So we'll kind of put that on hold for now. But when I zoom in, my computer goes a bit crazy. But number 5 and number 6 are definitely 2 important rules. This is a rule we're talking about where you can expand logarithms. So rule 5 and 6 are the most important. Rule 5 says that if you have a logarithm, it doesn't matter what the base is. And remember, the base is this number down below. But inside of that, if you have X and Y, you can separate that and you can turn it into an addition. So log base b of X times Y can be expanded to be log base b times X or log base b times Y. You can kind of think of this like, remember when we had, if we multiplied X cubed by X squared, you guys realize, this is a long time ago now. Oops, sorry. It would be X to the 5. You would add the exponents. Because logarithms are directly related to exponents, this is where this rule comes from. If we multiply X and Y in the log term, we can kind of go backwards and separate them by adding. Similarly, let me erase my writing here. If we had the exact same thing, but I did division of exponents, You guys know that we could simplify that as 3 minus a 2. Well, the same thing goes for rule 6. If you have a logarithm, and again, any base, it doesn't matter what the base is, b, doesn't matter what b is, if it's x divided by y, then you can turn it into subtraction. So rules 5 and 6 are definitely the most important. And rule 7, actually. You will use, or some of you might use rule 7 a lot like I used it a lot in advanced chemistry, so in advanced physics. So any of you guys looking for the college or this is the college, but it will be a university. So any of you guys interested in the university programs that are going to be offered, rule 7 is one we used a lot in advanced chemistry and physics courses. If you have an expression, so like log base b, and I'm going to show you examples of all of these, but log base b times x to the power of p. One cool property of logarithms is, and we're going to practice this today, is you can take this p and move it in front, and it will be equal to the same thing. So the 3 big rules are 5, 6, and 7. Rules numbers 1, 2, and 3, you can basically do those with your calculator, right? You put your numbers in, it's going to tell you what the answer is. I wouldn't worry too much about rule 4, and rule 5, 6, and 7 are definitely important rules. Again, and I keep bringing up chemistry, physics, but if you guys are going into any of the degree programs, you might have to do a calculus course. Calculus is a type of mathematics. It's pretty advanced. You'll use these properties as well. So again, anybody in this course who wants to go in and maybe get a degree, you're going to see a lot of this. And actually, even if you're doing a diploma program, you're going to use this in other courses as well. So let's look at some examples. I mean, these rules are fine, but let's practice. Okay, let me just get rid of my writing here. So A, B, and C are good warm-up type questions. D and question D can be, most of these I guess can be done in your calculator, yes. So I'll give you a little hint. If you guys can't remember something like this question on, say, the final exam, you could test all of these on your calculators, but I can use my rules to figure these out. Okay, so let's look at the rules to figure these out. Again, just a disclaimer, you could see which are equivalent using your calculator. You would just enter the numbers and see which are the same value, like the same decimal. The only problem with that is if you were dealing with variables, you couldn't do it. So I'm going to zoom out a little bit here because I'd like to have my rules here. So hold on, there we go. Practice A. Which one of these will be the same? Log of 3 times 5, log 3 times log 5, and then log 3 plus log 5. Now, when you just see the word log, it's assumed that the base is 10. This is the literal log button on your calculator. So if you were doing this on your calculator, you would just press the log button. What I mean is you would press this button. You wouldn't press this button. Sorry, that's supposed to be a square. Okay, so when it just says log with no number as the base, only use your log button. Again, though, you don't need a calculator for this. The rule 5 states that log of 3 times 5 would be the same as log 3 plus log 5. So the ones that are the same are the ones that I've circled. Let me circle them again. So this one and this one would be equivalent mathematically. And if you guys don't believe me right now, you can test it on your calculator. They're the same. Okay, what about question B? we have log 6 divided by 5. And then keep in mind, it's in brackets, so it's logarithm of 6 over 5. Is that equal to log 6 over 5, or is it equal to log 6 minus log 5? And just like before, except we're going to use rule 6, log 6 over 5 is the same as log 6 minus log 5. It's funny, it's interesting talking about this. Just a side note, if you're wondering what's the point of logarithms, what they do is they take very small or very, very large numbers and they put them on a more simple scale. So the easy example I can give you is, if you've ever heard of pH in chemistry or biology or in science, pH is a number that uses logarithms to make it easier. So, some people say, you eat acidic food or eat basic food, and they'll say, okay, a lemon has a pH of 2. Well, the real value of the strength of that acid in the lemon is a very, very, very specific number with lots of decimals, very large or small number. In chemistry, typically we're dealing with very, very small numbers, like 5 times 10 to the minus 8 and things like that. And what a logarithm does is it turns a very large or small number into a more reasonable scale. So just if you're wondering, in math, we don't really care about that, because in math, we're just learning how to manipulate logs. But once you guys get into physics or chemistry or biology, you'll see what the point of a log is. It applies the mathematics. Actually, I think in topic 28, which we might get to today, we're going to apply logarithms. Okay, so compare the expressions which to our equivalent number C. C is rule 7. Log of 20 to the power of 2. Is it equal to the entire thing squared? Not just the number 20, but the entire thing squared, or is it equal to 2 log 20? Well, I know the rule is, rule 7 says I can bring that exponent down into the front. So for C, whoever created this question wasn't very creative. In A, B, and C, the first and last terms will give you the same number. And again, you can try this on your calculators to prove it to yourself. Number D is also rule 7. There's just a little bit of work we need to do here. Log root 4 is the same thing as 4 to the 1/2. Okay, and this one's fine. And this one is the same as bracket log 4 all to the 1/2. So if you look at rule 7, it specifically says that it's only when that x term has the p. It's not when the whole logarithm is squared or cubed. So D, the answers are these two. I can take this 1/2 and bring it out front. So these are equivalent. Now, this isn't really a big question or an important question, because what we're going to do now is, calculate or look at examples of expanding and working with logarithms. And this is actually pretty easy. This was supposed to be on your test. Actually, originally, your test was going to be up to topic 28, but myself and the other instructors were going a little fast, so we had to slow it down and not cover as much. So luckily, I think your test yesterday went pretty well. So, but this was supposed to be there. You will see this on the final exam, of course. So this is a pretty, it's not too easy, but I'm going to show you a couple of these examples. There's 3 examples here. It looks like so much work here. It's actually not that much work. And then I'll get you guys to practice a couple. And then we'll look at another part of this. We'll try it with some numbers. So we're going to do it with x's first, then we're going to try it with numbers. Oh, and one thing I'll mention about the numbers is you guys are lucky because your calculators, like I'll just kind of skip ahead here. This, you guys could do the entire thing on your calculator. You guys have calculators that are much more powerful than what I had when I was a young math student. Unfortunately, though, for questions A, B, and C, you cannot use a calculator because there's no way to put variables in. Not on the Casio that I have. You guys might have something crazy. So what this question is saying is it's telling you to expand the logarithms. And we're going to look at today expanding them and then kind of shrinking them. We're going to make them big, make them small. But first, we're going to learn how to make them bigger. Okay, so step number 1. These numbers are divided. The first thing I can do when I look at this is I can separate this as a subtraction. So this would be log xy cubed minus log z squared. I didn't change any numbers. I didn't mess with any exponents. All I did was turn this into subtraction. Okay, there's still more work to be done here. Like what this question is asking you to do, by the way, is expand. Make this as big as possible, which is not normally what we do in math, but it is good practice. Now, there's a few things that I also notice. I can actually separate these terms and I can do something with the exponents. So because x and y are added, because x and y are multiplied, I can turn that into an addition. And then my last step, so guys, I'm using rule 6, then rule 5, and then rule 7. My last step would be I could take the 3 and put it in front and the 2 and put it in front. And halas, that's it. Not bad. We use property 6 to remove the division, property 5 to remove the multiplication, and then property 7 to take away the exponents. Pretty good. This isn't as, I'm going to go a little quick through this part because this isn't as useful. Typically in math, what we would do is we would go the opposite way. We would make a big equation smaller. You'll see, we're going to do all this stuff today. Okay, question B. Very much like question A, we'll use our properties. We'll first use property 6 to turn the division into a subtraction. So log of square root x plus y, all divided by 10, becomes log square root x plus y minus log 10. All right. Nothing I can really do with log 10. You could leave it like this if you wanted to, because this question isn't really asking you to solve. But if you put this in on your calculator, you would get a 1. So if you're wondering how log 10 magically turns into 1, just put log 10 in on your calculator. Like personally, I wouldn't care if you did this because I'm not asking you to simplify. Basically, I'm asking you to make this as big as possible. So again, this is a bit of a weird question. This isn't so much of a final exam question as it is teaching us things we're going to use in a few minutes. Now, I can take this 1/2, put it out front, whoops, not there, out all the way in front, and I get my answer. Okay, and again, if you said for your answer -1/2 x plus y minus log 10, that's totally fine. The book just decides to solve the log 10 because you can very quickly put this in on your calculator. Okay, let's look at a crazy one. C. C is obviously designed to be a little bit crazy, but it's still not that bad of a property. Or not bad of a question. There's only one very important thing that you need to keep in mind, and it's the first part, rule number 7. Well, actually, it's this thing we need to consider first. First thing I would do is I wouldn't write this as the index 5 root, 5 root, I'll call it. I would rewrite this so I get a nice exponent. So this would be log base b bracket x to the 4, y to the z3 to the 1 over 5. And again, that's review from the radical stuff we did a week ago, maybe 4 classes ago. Now I can get started with my rules or properties of logarithms. So property 7, I'm going to first take the 1/5 and move it. Well, here, I'll do it here. Take this 1/5 and move it in front of everything. Now, very, very, very important. This 1/5 is for all of this. So what I do in all of the subsequent steps, like all of the future steps, is I put brackets here because the 1/5 belongs to this entire bit of information. So the 1/5 belongs for all of this. Okay, so rule 6, I can take the division and turn it into subtraction. Sorry, my brain's not working. I can take the multiplication, turn it into addition. Then I use property 7 to move the 4s in front. Keep them inside the brackets. Okay. So I don't know. I think here, like this isn't really a step. Like the book isn't really doing anything. But what they're doing, what I did, is I move the 4 in front, and I move the 3 in front. Now this is a totally good answer. Perfect answer. You could distribute the 1 over 5 in and multiply it out, but this is a perfect answer. If you're wondering where this comes from, they just multiplied each term by 1 over 5. But you don't need to do that. All right, well, let's let you guys practice now. So, well, why don't you guys try a couple, try these. So try just these 4. I'll zoom in a bit. There we go. So try C, D, E, and F. And of course, as you know, I'll be back in a minute. We'll look at your answers. You can type them in the chat. It'll be a little challenging, but you don't need to. Just take a couple minutes and we'll look at the answers. All right. Cool. So let's check out some answers to this one. All right. I'm not getting a lot in the chat, but that's okay. These are kind of hard to type out anyways. But they are pretty simple once you know your rules. So something like question C, I could expand this to just be log 6x plus, and you don't need the brackets. I don't know why I'm putting brackets there. Plus log 6y plus log 6z, or z if you're Canadian. They're all multiplied, x times y times z, so I can turn them into addition. Something like D and E are very straightforward, meaning I'm going to use what's called the power rule, or rule 7. So I would just take log 5, put the 4 there, and keep my x. Same thing for E. I would say log 7z, and I put the 1/3 in front. Okay. What about something a little bit more complicated? I'll show you a tough one as well. I think maybe I'll do like something a little more challenging, like
Mr. But you said that the power for all of the log here is just for the z, or just for the x.
It's inside the brackets, so the power is just for the x or just for the z. Does that make sense?
So it's for log also.
It's the rule, right? Like if you had log 5 in brackets times x all out of 4, there's no rule for that. We can't do that. There's no rule. The rule says that if this term has an exponent, we put it in the front, or we can put it in the front.
Okay.
So I'll show you guys a tricky one in a minute. Okay, what about F? Log 4. Now, let's do this piece by piece. Log 4, we have A. I'm going to add that to log 4 of B, and C I subtract because it's division. And and you could do this in piece by piece if you wanted. So I could go log A times B minus log 4C. Then I could keep expanding it. Or you could do it all in one step like I was going to do right at the beginning, right? You don't have to show all of these steps. Whatever you're comfortable with. Now, you might want to show some steps with some of the harder ones. So let me show you a harder one here. They're all pretty equal in difficulty. Let's look at the let me just see. L is a good one to look at. Okay, now I don't know if I'm going to have enough room for L. So let's see here. First thing I'm going to do with L is I'm going to rewrite this as log AB squared over C, all to the power of 1/3. Now, when again, I just had that question, all of the term inside of the logarithm is 1/3. Not the logarithm itself, not the word log, the numbers inside. So step number 1, I'm going to put the 1/3 in front. So 1/3 log AB squared over C. Okay, that's step 1. You get a mark for that. Now I'm going to start breaking it down. But the key thing to remember here is you need to keep the 1/3 for everything. So I'm going to go log of AB squared minus log C. I'm going to do this piece by piece. So the AB squared is divided by C. So I'm going to turn that into subtraction. Then I'm still going to keep my 1/3 log. I'll go A plus log b squared minus log c. And then there's one more thing I can do. I can bring the 2 down in front. So 1/3, all brackets. If you don't put the brackets here, you will not get full marks. Because if you don't put the brackets here, you're just telling me that only the log a is multiplied by 1/3. The brackets in math indicate that everything is multiplied by 1/3. And that's it. You don't need to go any further than this. If you were solving this, like if we were going to get a number, you could distribute, meaning multiply the 1/3 in, but you don't need to. It didn't ask you to do that. It just said expand the logarithms. So this is all good and useful, but it's not what we really care about. What we really care about, wink, 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 is the next section. This would be what I would call simplifying logarithms. See if I can get rid of that. Can I get rid of that? Yes. In some applications, aka in most applications, it might be necessary to simplify the logarithms as a single. So what we're going to do is we're going to go backwards from where we were before. Okay, so what I mean is, instead of expanding them and saying multiplied, we turn it into addition, division, we turn it into subtraction, we're going to go backwards. So for like example, if you look at number A or question A, we have all subtraction signs here. So this one is very tricky. The first thing I'll tell you about question A is you could actually just do this one on your calculator. Now, why? How come you can do A on your calculator and not B and C? Well, A has all numerical values. So if you guys see a question with numbers, which we'll look at a bit later in topic 28, you don't need to do anything. You can just put the numbers in your calculator. You be very careful and simplify it that way. Now, if you don't want to use your calculator, and again, in B, we cannot use my calculator. And C, the same thing, you cannot use your calculator. So in A, if you didn't want to use your calculator, there's two ways to look at this. The easy way is that you have log 560, and you're subtracting from that a 7 and a 5. So right away, I could simplify this as just log 2 560, and I'm subtracting a 7 and I'm subtracting a 5. Easy, right? Nothing too difficult about that. If that doesn't make sense, what happens here is, and this is why this one would be tricky without your calculator, is what we're technically doing is we're factoring out a -1 from the two terms. Or what I mean is, this expression here is the same thing as saying log 560 minus log 7 plus log 5. It's the same thing. So the 7 and the 5 go on the bottom. 560 divided by 7 times 5. And again, when I did this myself, I didn't even do the factoring. I just said, well, it's 560 over 7 over 5. Like the 560 is over 7 and 5. So whatever you're comfortable with. And again, you can do this one on your calculator. Well, the next step, for example, I would do on my calculator. 560 divided by 35 is 16. And then you have to use your calculator for the last part. There's no way to do logarithms without a certain chart or table, or more specifically, a calculator. Your parents, or maybe not your parents, but my parents, because I'm an old man now. My parents are in their 70s, and when they did this in school, they didn't have calculators. They had to look up the values in a booklet, in like a data book. So if your parents ever tell you they had it harder, in some ways they did. because you guys can just use, computer apps and websites like Wolfram Alpha or a calculator to do it. Okay, what if we can't use our calculator? Well, we have to follow the rules. And this is kind of fun. I'm a bit of a nerd, I guess. I find this fun. It's kind of like solving a puzzle. So I'm like applying the rules of the puzzle to make this look as simple and pretty as possible. Okay, so let's look at this. I would start backwards, meaning I would go kind of through your rules in a backwards order. What am I trying to say there? Like, get rid of the powers first, for example. So what I mean is I'm going to apply rule 7 first. So what I mean is I'm going to take the 2 and go backwards from what I did before. I'm going to take the 1/2, not the negative, just the 1/2, and put him there. And I'm going to take the 3 and put him there. So again, in the first part of today's class, we made them bigger. Now what we're doing is we're making them smaller. And they both have their uses in science and math. Okay, so by doing that, I'll get this. And this looks actually pretty simple now. There's not really a lot to worry about. What I would do is, just to make it easier in your head, is to group or put the terms of positives first. Just so I'm going to do my multiplication step first. You do not need to do this. You do not need to do this. But the book suggests to do the adding first. So this is positive, this guy's positive. So log x squared plus log z cubed would be log of x squared times z cubed. Now with my subtraction term, I put it on the bottom as division, and I get this. And this is your answer. This is okay too, but this is fine. So we moved the exponents back into the logarithm. We then multiplied any terms that were added. We divided any terms that were subtracted, and then that's it. Halas. This, again, you will need this, any of you going into the degree program for calculus. This is huge, huge importance. Both of this, expanding it and shrinking it. Okay, so let's look at number C. C is by far the hardest one, right? Like C is a very challenging, well, about as hard as you could ever see them. So this is, first of all, this only works if they have the same base. So you can only do these properties if it's the same logarithm. So it has to be logarithm or log 5, like they have to be the exact same base, and they are. Now you'll notice that I have brackets here. Do what's inside the brackets first. Don't do anything with the 1/2 yet. So the first thing I'm going to do is I'm going to, since this is a subtract sign, I'm going to turn it into division. So this becomes log 5 of this guy, x squared minus y squared, over log 5 of x plus y. So I use that that subtraction to turn it into division. Okay. Next step. The next, depending on the question, you don't, because this question is, I'm asking you to shrink it. But the next step, the book decides to factor it. So what's going on here? Right? Remember factoring, and we told you how important factoring is? X squared minus y squared is a difference of squares. So that would become x plus y, x minus y. We did this back in topic. We started factoring in topic like 12 or something. So we would expand the top and factor it. And the reason the book does that is because what you can actually do by factoring the top and expanding it, just like you did in your test yesterday, we can cancel terms. So this question becomes 1/2 log 5x minus y. And then I can put the 1/2 over. And there we go. I get my answer. So let me just go through this one again. This one is by far the toughest. Like this would be a very difficult question. So let me just kind of cover this one again, and then I'll get you guys to do some practice. And I'll get you guys to do some simple and medium type ones. So first things first, I left the 1/2 here and I took the subtract and turned it into the division. Remember, I'm trying to simplify this. Now, a big part of simplification of algebraic expressions is to factor, and x squared minus y squared is again a difference of squares, which turns into this example. This is back from factoring.
Mr. I want to ask you if it all the terms is minus. Can I put log 1 over the all the terms? All the thing?
Yeah, I know what you're saying. Yeah, if like everything was negative, see, that's tough because like if you had 1 minus log, no, I don't. That's never going to happen. Put it that way. No, you can't do that. No.
Okay.
Okay. Like what he was saying is if every logarithm was negative, would you put 1 over? I mean, technically you could, but that's not what we would do here. The good question though. So, so back to this. So I factored this. And again, if you're confused, you really need to review factoring between now and your final. Make sure you practice factoring. By factoring this, I realize I can cancel these terms, leaving me with this. Then I take my 1/2 and put it over here. And there we go. Done. No problem there. Well, I mean, that's a tough one. Okay. So well, let's do what we did last time. Like let A and B are very simple. Let's kind of do some easy to medium ones, and let's get your. I'm going to ask you guys to try these. So why don't you guys try these 4? I'll give you another couple minutes, of course, and then we'll check your answers.
Why I ask you this question? Because of B.
Because of what?
Question D.
B. This one? I'm confused.
Question D.
B, I'm looking at B, but they're not negative, so I don't get it.
Not B, D.
Oh, D. Again, they're not all negative. So no, you don't put 1 over. You're going to put them over the x, or sorry, under the x. Like this is positive. So they go under the x terms. Does that make sense?
Yes.
Okay, perfect. So take a few minutes, try these, and I'll be back. We'll look at the answers. right, another minute or so, we'll look at some, like I'm giving you 4 really, as long as you try 1 or 2 of these, like just to see if you can, because they're all the same. Um, it's just practice. So you don't have to do all 4, but if you could try at least one, pick one, try C, try D, try E. It'll really help you. In my opinion. So, again, I know you might not have time to do all 4, but they're all the same. So just try at least one of them. And in like 2 minutes, I'll go through all of the answers. All right, let's check these out. Again, there's 4. They're all of almost equal difficulty here. So first things first, what we would do is I'll zoom in. I sometimes this doesn't work, but we'll see. I'll move the exponents back into the logarithm. So this would be log 3x squared minus log 3y3 plus log 3z. There's nothing with the z. Now, again, like the book mentions to group the positive terms, but really what this means is we're going to have a division and we're going to have a multiplication. What we're going to do is we're going to say log, like you can look at it this way. You can do it piece by piece. Log x squared over y cubed plus log 3z. And then this gets multiplied. Now, when it's multiplied, I'm just going to simplify it, meaning not simplify it, but I'm going to write it up here with the x. Okay, so I am taking the x and I'm dividing it by y3 and I'm multiplying that x by z. And that's it. Not too bad.
Log 3. Log
Oh, yes.
3.
Yeah. Very important. That's very important. Thank you. Log 3. If these had different numbers, you cannot do this. And do you know what that's like? That's like saying what's x squared times y squared. And you guys did like, oh, it's xy4. Like, no. If the bases are not the same, you cannot combine them. Logarithms and exponents are the same thing. So the rules of logarithms are the rules of exponents, just kind of reversed. Like if we had time and if you guys, if we were going really deep into this, it's kind of fascinating, but that's not what this course is about. So, but maybe in a future course like calculus, you'll really kind of get into this stuff. So I have log 2 x to the 1/3. Yes.
You cannot add log 3x with z.
Do you mean for question C?
Yes.
I'm not adding them, I'm multiplying them.
Oh, okay.
Yeah,
Okay, thank you.
yeah, no problem. They're not added, they're multiplied. Because they're added here, they get multiplied down here. That's rule number 5. You'll see this again in a second. So 5, so log y to the 5 minus log 2z cubed. And the same thing, I'm going to say log 2. I can say x to the 1/3 over y to the 5 multiplied by z to the 3. Oh, sorry, not multiplied, divided, because it's another subtraction. Boop, boop. Right, so this is, we're going to take x cubed, or sorry, x to the power of 1/3, and we're going to put the y5 and the z3 on the bottom because they're both divided. So they both go on the bottom. All right, D is probably the hardest of the 4. All right, let's see. I don't know why I picked to do all 4 of these. Log 3a squared minus log 3b to the 1/4 plus log 3c. So again, same thing here. So what I did, guys, is I took the numbers in front and moved them to be exponents. Now I combine my terms. So log 3a squared over b 1/4 times c. Times c on the top. Right, because it's plus, I'm going to take the log a and multiply log a by c. So it's a squared plus c, or a squared times c when I put it into the logarithm, all over b to the 1/4. So if it's negative, you put it as division. If it's positive, you put it as multiplication. All right, last one. I'm going to do one more, actually. I'm going to do a harder one on the bottom. Log a minus 1/2 log b minus 3. Oops, sorry, I'm just writing it out again, aren't I? Let's put the exponents up here. So log 5a minus log 5b to the 1/2 minus 3 log c to the 5. Sorry. Log 5c to the 3. There we go. My brain is thinking of this step ahead and I'm writing different words. So the 1/2 goes up here with the b. The 3 goes up here with the c. Now they're both subtracted. They're both going to be divided. So this would be log 5a over b to the 1/2 c to the 3. Whoop. Ooh, that's a weird looking face. There we go. Okay. Let's look at a harder one. And like G and H, they're all the same. It's the same thing over and over and over and over. But there's a few at the bottom that are like M and N are a little different. So let's look at N. Now, there's a few things I can do. There's it doesn't really matter what order I do these in, but well, let's start with the property that you guys would probably see first. I think, like, I don't know how good you guys are at factoring, but hint, hint, there is factoring here. So the first thing you guys would probably notice is that these are subtracted. So you could rewrite this as log x p squared minus 4 divided by p minus 2. Right? This subtraction turns into division. Pretty normal. But, so you'd get a mark for this, no problem, but there's something special here. And this is the challenge. And when I was a student doing like calculus, hold on, I just got to open up a different menu here. When I was a student doing this in school, I'd always miss this. You know, I'd be doing a test and my brain would be working. So, you know, tests are stressful and I would miss this. this is a difference of squares. This we can factor. P2 minus 4 is the same as P2 minus 2 squared, which is a difference of 2 squares. So this can be factored to be P plus 2 and P minus 2. Right? Again, you have to practice factoring. Like I think if a student said, what should I like practice the most for my exam, I would say factoring. It's so important because you'll notice we're doing it again in other topics. Oops. So this would be P plus 4, plus 2, P minus 2 over P minus 2. And the beautiful part about factoring is we can get rid of these. See, I love it when these questions have a lot of room. Done. Woo. All right, cool. So there's still more. There's still more in topic 27, but topic you'll like the next part because, well, I don't know if you like any of this stuff, but the next part of this is everything we've already done. I don't know how much you guys studied logarithms for your test, but there was another type of logarithm mentioned very briefly in topic 25, and it was a natural logarithm. This, guys, is nothing new. Literally nothing new. Well, people use the word literally wrong all the time. I mean, it's basically not anything new. Again, this kind of relates to chemistry or physics or biology, meaning an applied mathematics situation. Because it's used so much in different schools of engineering, medical science, and whatever school you're going into, maybe business. I haven't done as much with the business courses as I would have liked, but a lot of people use a different form of logarithm. The irregular logarithm has a base of 10, but another important logarithm is called, the natural logarithm. We did this back in topic 25, but we didn't really do much with it. I just told you that it was a button on your calculator. Now, one thing I'll mention is this looks like IN, it's actually LN. So the natural logarithm is a logarithm. The only difference for a natural logarithm is that it's to the base E. So a normal logarithm is to the base 10. A natural logarithm is equivalent to a logarithm with a base E. E is a constant, which not really important for us. It's just a button on your calculator. So E creates a natural logarithm. I know this seems confusing. Like, why are they doing this? Why wouldn't we just use log base E? And you can blame scientists for this because it was used so much, they just gave it a different button on the calculator. What I'm trying to really maybe poorly emphasize to you is it is a logarithm. There's nothing new about this. The rules are the same. I don't even need to go through these rules. We already did them. Rules 1, 2, and 3, you can do on your calculator. And again, even rule 4, you can do on your calculator. Rules 5, 6, and 7 are the big rules. Literally no difference here. If it's a natural logarithm and it's x times y, add the exponents. Add the factors. If it's division, subtract the factors. If it's an exponent, bring the p down front. Same rules. Okay. One thing you need to be careful about, though, is question A is actually a good one to be careful about. Okay. So question A. ln e equals 1. Sorry, ln, ln, e, natural logarithm of e equals 1. Now, that's a property. It's property 2. But how could you do this on your calculator? Well, I kind of showed you this the other day, but let me show you again how you could do question A on your calculator. Hold on, let me open up Google, Casio, whatever. Years ago, I used to have a picture of this saved on my hard drive, and I could just open it instead of going to Google. Anyways, that was long, many semesters ago. Just give me one setting here. Size. I guess this is my best bet. Okay, open a new tab. All right, I'll share my screen. You'll see, oh, this is beautiful. I finally found a big version. I should save this to my computer. Okay, so what's this E business? Well, conveniently, E is above ln in your calculator. Sorry, I say ln. Ln is ln, so natural logarithm. So if you had to enter this on your calculator, you would press this button, the ln button, ln button, and then you would enter E. Now, the book just says E. So if the book said E, what it would look like on your calculator is it would look like ln bracket E, and then you would just put a 1 there. Okay, so if the book is asking you, if the book says solve ln E, ln-E, your calculator will look like this. You can access the E using the shift button. I think you guys are pretty much pros at your calculators now. I hope you are, because a lot of this can really help you. And when you do this on your calculator, and I'm just going to double check to make sure I'm not lying to you. Oops. Boom. Yeah, it's equal to 1. Cool. So E, if you see E, that is a button on your calculator. Okay, back to the notes. New share. That's a good calculator. Okay, so these aren't the best examples. These are just kind of getting us warmed up. So A and B you can do directly on your calculator. Ln E equals 1, ln 1 or ln1 equals 0. If you don't believe me, try it on your calculator right now. Press ln, press 1, it will equal 0. No problems there. Now, this is an interesting one. C is a little bit tricky. For C, what's actually happening here is we're using, well, I guess it is property 3, but I can explain this a little easier than property 3. If you did this, so ln or ln e x plus 1. Well, we know we can take the exponent and put it down front. So this would be x plus 1 times ln e. And we know that ln e equals 1. We just did it in part A. So really, for question C, you could just apply property 7, the power property, and then just solve ln e. I personally, I find that a lot easier than trying to memorize all these properties. If you know properties 5, 6, and 7, you're perfect, like no problems there. And you don't have to worry about property 4. Okay, all you need to worry about is 5, 6, and 7. All right. So now let's do some real calculation. Oh, actually, you guys got calculators. I'll let you guys try these. If you're wondering, this is just 3 to the x. This is just 2x plus 3. Don't worry about these. But why don't you guys try? Well, A, B, F. Try those three, A, B, F, very quickly. I'll give you a minute or two for those because, again, you can put these in on your calculator. So A, B, and F, try them on your calculators right now if you have your calculators. Let me know the answers. I'll give you, because it's a calculator question, I'll just give you like 3 minutes or something. So, or 2 minutes. Try A, B, and F on your calculator. Okay, let's have a little look at these. Again, you can put these into your calculator, no problem. So I think without even using my calculator, I think number or letter A would be just 2. You can try this in your calculators, and it is certainly 2. So this is 2. All right, what about B? Again, you can enter this into your calculator. Now, ln of 1, ln of 1 is 0. So if you tried this on your calculator, you would get 0. And then for the next one, you'll get something a little different here. So you can, again, enter this on your calculator. And you would get a -6. All right, no problem. Cool. So that's it. C, for C, you could bring this guy in front and your answer would be x plus y times ln E, which is just a 1. So you would just get x plus y. All right. Again, this isn't really what I'm trying to get at. What I'm trying to do is then now let's apply the properties like we did with logarithms. Let's apply it to these. This is literally nothing new. We're doing exactly what we did before with logarithms, except instead of log, we're using ln. That's it. That's it. So just hold on one second. Okay, sorry. Okay, so for number 1, again, nothing new. First things first, because we have a division sign here, I'm going to subtract here. So ln E minus ln x squared plus ln square root of y. Okay, well, ln E, you can do again, if you hear me say ln, like L-O-N or L-A-W-N, I mean Like if I speak the word ln, it means natural logarithm. Okay. It's just how, because I know like log in English is pronounced log. ln is not a word in English because there's no vowel. It's a sound. So ln is like lun, I don't know. Anyways, if you hear me say lon or lon, I mean ln. So we know that if we put ln e on our calculator, we're going to get 1. That's no problem. But what we need to do is we need to expand this. So because they are multiplied, we're going to change it to addition. And then the last thing we can do is we can take the 1/2 here and move it down front. Nothing new. If you changed this to log and you put the numbers in, it would be the same thing. The only difference is we're using ln. So again, like there's a million problems here to practice. I don't know. I'll just show you one. I'll do a hard one with you. And you guys can practice this later if you want. It's just, we've already done this. Just 1 second, actually. Actually, there's someone at my door. Just try G, very hard one. Just take 1 or 2 minutes and we'll look at the answer. I just got to answer my door. I think it's my water person.
Come on, baby.
All right, let's have a look at this one. So same thing, right? Like if this said log, it wouldn't make much of a difference. We're going to follow our properties. So first property I'm going to do is, because it's division, I'm going to subtract. So this would be ln x cubed root y divided by, divided by subtract, ln e2. Okay, we can actually solve this, but I'll do that in a minute. Now I'm going to expand the middle. So ln, this would be x3 plus ln root y minus ln e squared. All right, now let's simplify. Or let's finish this. I mean, not simplify, but let's finish this. So I'm going to put the 3 in front. Remember that this a square root is to the power of 1/2. So I'll put that in front. So 3 ln x plus 1/2 ln y minus, and you can do this on your calculator, 2. You could, if you wanted, you could leave it like this. But if you wanted to, you could change it to a 2. Whatever you want to do. Like I wouldn't take off marks if you left it as ln e to the power of 2. All right, so let's review. We're pretty much done for the day, by the way. I'm just going to finish this topic because there's only one part left. We might as well finish it. And then that'll be basically it for today. Tomorrow we'll get into solving these. Now, this is challenging. Solving these can be hard because, well, no, I don't mean to scare you, but solving these is a little bit more work, but much more useful because you know, we're going to have to actually solve for x.
Mr. Can I see the answer again? For
Oh,
J?
yeah. Yeah, sure. I'll leave that up for 1 second. Yeah, no problem.
I'm first, Mr.
All
Thank
right.
you.
No problem. No problem. All right. Let's have a look. Again, like, so I know this has been a long one. We've been at it an hour and a half now. This is like, I just might as well finish because we're so close. And the reason that this is easy to do is, again, we've already done this. Again, just change the word to log and it's the same type of question. Now, I don't mean you can do that. Do not, and if you had this on the final exam, do not change the word to log. But in your brain, it's the same process. This is, of course, a very challenging one because, again, we can factor this. This is another difference of squares. The book really loves difference of squares in here. Okay, so write the question says write the expression as a single logarithm. So what we're trying to do is, instead of expanding it to be big, we're trying to shrink it to be small. All right, so step number one, I have all of these negative signs. What does the book say as well? Okay, so what the book says to do first, and I agree, and it only because I didn't see it here, let's get rid of this 2 first. Let's put the 2 up by the x. We typically start with rule 7 or property 7 and do that first. So let's put the 2 up. You'll get this. No problem. Nice. Okay. Now I have this term and I'm subtracting both of these. So the book says factor them out, turn them positive. Realistically, when we did this, we just kind of skipped to the bottom. It's x squared minus 9, subtract both of these. So what I'm going to do is I'm going to say x squared minus 9 divided by both of these. And they become multiplied on the bottom. Basically, I'm going to move both of them over under the division sign. Okay, you can do these if you want. You can factor it, but you don't need to show me those steps, right? I just say, okay, it's x minus 9 divided by this and this. All right, this looks good, right? You might think you're done here, but oh no, you are not done here because you need to factor another difference of squares here. X squared minus 9 is x squared minus 3 squared. Another difference of squares. So this becomes x plus 3. Sorry, x minus 3. Excuse me. I highly recommend you recognize differences of squares. I don't know if that's in your formula sheet, actually. I don't have it with me, but difference of squares might be in your formula sheet in your on the back of your page. Like sum of cubes and difference of cubes is on your data, your formula sheet, but I don't have one with me. Oh, wait a minute. No, never mind. I don't have one. But I'll check next day. Once I start marking your tests, I'll let you know. So I factor the...
It was in the last page in the test.
It was or wasn't?
It was.
It was? Okay, good, good. Thank you for that. Yeah. So this is this property or this factoring rule is in your data sheet you'll have it for your final. The thing about we'll talk about this later because I know you guys are probably wanting to get out of here. I'll just quickly say that we've cut some things from this course, which means there is a lot on that data sheet you don't need, but difference of squares and difference of cubes, just make sure you keep an eye out about that. So once I factor, I can cancel and I'm done. Okay, you guys are probably tired. Rather than put you to work, let me do a couple for you, and then that'll be it, right? What I recommend though is after this class, if you have the energy in you, try a few of these. It would be good practice. So A is a tough one. Well, pretty tough. Let's start with an easier one. Let's start with D, and then I'll do A, and then halas. That's it. So first things first, I bring the 4 up and the 3 up. So I would simplify this to ln x to the power of 4 minus ln y, to the power of 3 minus ln z. Now, what I'm saying is you have ln x and you're going to subtract or divide that number by this guy, and you're also going to divide it by this guy. So this gets simplified as ln x4 y cubed z. Right? I don't know how you guys find this stuff. It's not too bad. Let me mention something about f. I think earlier a student had a question about this. If you were going to do f, rewrite it. Put the positive first. 3 ln y minus ln x minus ln z, because this is telling you what, basically the positive is on top and the negatives are on the bottom. So this would become ln y cubed divided by xz. Okay, so I highly recommend put the positive guy first. When you're adding and subtracting, you can do that in any order. There's no, in BEDMAS, there's no order for adding and subtracting. So we can switch them around. We can move them. It doesn't change the equation. Okay, let's do a hard one. And then halas, that's it. Okay, so immediately I see this and I'm just going to make a note. This is a difference of squares. This is equivalent to x minus 4, x plus 4. The book really likes differences of squares. Now, before I do that, let's put this together. Then I'll worry about the putting in the factor. So I'm going to get ln x plus 4 divided by x, let's keep it the same for now, I'll factor it later, times x on top. Right? This x goes on top. So these guys are multiplied together because they're both positive, and the negative goes on the bottom. Oh, never mind. I was going to try to erase something, but it wasn't working. So here we go. Now I'm going to factor. So ln, actually, typically you would write the x first. It really doesn't matter though, guys, but a math person would typically write the x first. It doesn't matter. X minus 4, x plus 4, cancel, and you're done. Woo! All right. I did go a little quicker through that part because, again, it was nothing new. It was the same properties with, instead of the letters L-O-G, it was the same, we just use L-N. So guys, that's it for me today. I'll get your tests back as soon as I can. I don't know if I'll get them done tomorrow, but I don't know if I'll get them done before your class tomorrow. I'm going in to start marking them now, but you will definitely have your grades by this weekend. Or by after class on Thursday at least. So tomorrow you guys have class at 1:30. They might not be finished then. I have to mark 30 of them, but they will be done at some point on Thursday. So you'll have them for the weekend. All right, guys, that's it for me. Take care. Have fun. Be safe.
Thank you.
Thank you.